how would we rotate by 90 degrees? Let's say we start with the complex number 2 plus 4i. So that's represented by the arrow that goes 1, 2, 3, 4. Rotating that 90 degrees should give us this arrow, represented by the arrow that goes 4 units to the left and 2 units up. This is the complex number 2 plus 4i. This is the complex number minus 4 plus 2i. So we need a way of mapping from the complex number x plus yi to the complex number minus y plus xi. How can we do that? We use the property of I, that I squared is minus 1. So we multiply I times x plus yi. Using the distributive law, we get x times I plus y times I squared, which is x times I minus y. So the function we use for rotating by 90 degrees is f of z equals I times z. What about rotating by another angle? Well, let's start with this definition. The argument of a complex number is the angle measured in radians between the x-axis and the arrow representing the complex number. To see how to increase the argument of a complex number, we turn to a formula due to Euler, a remarkable mathematician who contributed to many areas of mathematics, not to mention music theory and cartography. Euler's formula states that for any real number theta, e to the theta times I is the point z in the complex plane on the unit circle whose argument is theta. Here, e is the famous transcendental number 2.71828 and so on. So here's an example. We plug in theta equals pi over 4, which corresponds to 45 degrees. E to the I times pi over 4 is this point in the complex plane. Notice that the arrow to that point forms a 45-degree angle with the x-axis. If we plug in theta equals pi, that corresponds to an angle of 180 degrees. So the complex number is this one, which turns out to be minus 1. So e to the I times pi is minus 1. Let's see how we can use the Euler's formula to rotate points by any angle tau. Any complex number can be written in this form. Z equals r times e to the theta I, where r is a real number, which is the absolute value of z, and theta is the argument of z. What we want to do is increase the argument of z. We'll use the exponentiation law. E to the a times e to the b is e to the a plus b. So if we start with the complex number z, which is r times e to the theta I, and we multiply it by e to the tau I, by the exponentiation law, that's the same as r times e to the theta I plus tau I, which is the same as r times e to the theta plus tau I. So we get a complex number whose absolute value is the same as the one we started with, but whose argument is theta plus tau. So the function that multiplies by e to the tau times I carries out rotation by an angle of tau.